We're Group 1, and today we're presenting on our ODK design. These are our group members, as you can see. This is the outline that we'll be following for this presentation. Introduction. The current ODK system, while essential, has become outdated and lacks flexibility for modern workflows. So we were tasked in designing a new ODK system. This redesign focuses on core features like managing projects and forms while introducing powerful tools like chart, filter dataset, union dataset, and joins. These enhancements will help users organize, analyze, and visualize their data more effectively. So let us now show you how this database design addresses needs and build a modern, scalable platform for the ODK community. I now invite my colleague who will speak on a conceptual schema.
Good day, I'm Afifa and I'll be explaining the conceptual schema ER diagram. The first part of this design is the project entity. The project acts as the container for related forms and their data. It organizes all aspects of data collection and analysis under one roof. Here you can see the project is linked to the forms entity in a one-to-many relationship. So for example, a healthcare survey project might have different forms for patient intake, follow-up visits, and feedback. So the form entity is where the data collection actually starts. A form defines the structure of the data being gathered, including its field and logic. Each form belongs to a specific project, but forms can also exist independently. For example, the project intake form might include fields like names, age, and symptoms. So the forms are important because they link to questions, submissions, and even data sets for analysis. Forms are made up of questions which define the specific data points to be collected. Each form can have multiple questions as shown in the one-to-many relationship in the diagram. Questions can range from simple text fields to advanced logic-driven queries. For example, referring back to the patient intake form, it may have a question about the patient's age and include a constraint ensuring that only valid numbers are entered. For multiple choice questions, we use the choice entity to store the predefined options. This ensures data consistency and simplifies analysis. In the diagram, you'll see that each question can have multiple choices, forming another one-to-many relationship. So now once this form is filled out, the responses are stored in a submission entity. Each submission is tied to a specific form, which creates a one-to-one relationship. The submissions are essentially the raw data that powers the rest of the system. So each patient's response to the intake form is stored as a separate submission ready for analysis. So now what do we do with all of this raw data? We have to actually analyze it. So in order to use that data, we have our data sets. Filter data set, which narrows down data based on different criteria like location or date. You have our join data set, which combines data from multiple forms. For example, it can merge patient data with their follow-up feedback. And our union data sets, which aggregates data from forms with similar structures. This makes it useful for comparing surveys conducted at different hospitals. In the diagram, these datasets all link back to the forms or the submissions, allowing flexibility and scalability in data analysis. Last but not least, we have our charts. These are essential for visualizing the data. Each chart is based on a single dataset as shown in the one-to-many relationship in the diagram. Charts make it easy to identify trends, patterns, or outliers. For example, a bar chart could show the number of patients treated in different hospitals, while a pie chart might break down their satisfaction levels. So that is my explanation of our conceptual schema ER diagram, and I'll be handing you over to my other colleague to explain our next diagram.
Hi, everyone. My name is Amira Mohammed, and I'll be discussing the logical schema. So what you're seeing here on the screen is a logical design schema which shows the new and improved Open Data Kit database system. Let's look at the entities and what they represent. So the project entity has three columns. Now, the first column has the primary key constraints, the second column with the attributes, and the third column with the data types. So the project entity represents a project being undertaken, a specific project being undertaken, and the attributes are project ID, which is the primary key that uniquely identify a project. And this would be in the form of integer data type. The name of the project, that would be in the varchar data type. Now, varchar is a data type in SQL that stores character strings of variable length. Description attribute, that is the detailed information about the project. And the country, that would be where the project is being conducted. And the business sector, which associates with the project. So those are the attributes of the project entity. Next, we have the form entity, and that represents the data collection instrument associated with the project. And the attributes would be form ID, title, and description of the form. Next, we have the JSON representation. That would be the JavaScript object notation, which is a standard format for storing and exchanging data that's both human readable and machine readable structure of the form. XLS form path, that would be the next attribute. That is the path to the XLS representation of the form. The XLS form is a standard created to help simplify the authoring of forms in Excel. Our next entity